Happy morning to all to you students. Today I am going to discuss about last part of this session, current electricity. In this chapter, we are going to discuss about the color coding of the resistance and cells. What is Joule's law of heating and Kirchhoff law, Wheatstone bridge and meter bridge. With this, some of the problems which is regarding to this one we are going to see in this sessions. This session little will be more problems. You just go through on this one. Okay, at the end of the sessions, I just provide you some of the homeworks problem. You just work out till now what are the problems I have been covered. All the problems, all which has been given as a homework in this session, it will be attached in the description. You just go through on this one. Okay, in this problem, find the value of color code resistance as shown in the figure. Now, this one, there are four color codes of the resistors. This one you can observe in some of the electronic instruments like radios and in radios and more electronic instruments. You can observe such type of resistors over there. And before going to that, what are the colors which depicts the resistors value that we can understand? Before going to that, you have to know about what colors that has been mentioned here. See, there are four colors in this case. In let me tell you here, in this four colors, see, one, two, three, and four colors are there. These four colors actually which has been described over here, the first color which can describe about the first digit, and second color is about the second digit. See, this is about the color first digit and second digit numbers over here, and third one is about the multiplier. Depending on this one we have to mention this one, and the last one is about the tolerance, about this much of percentage the resistor can be tolerate over the applied current. That one we are going to see here. Now in this case, the first one is a green in color. Green color you can observe in the in case of in this one you just go through on this green color, which is 5, and next one is orange color, that is 2. I just mentioned here this one 5, and the second one is 2, and the third one is that is about the multiplier, which is in orange color. Already they have mentioned this one, this is 10 power 3, and plus or minus this one what they have given the tolerance. In this case, silver here is silver, you can observe in this case. See, silver which has been given over here at the end of the table, that is about 10 percentage of tolerance. So I just mentioned here, this one I just mentioned here in this case, plus or minus 10 percentage of tolerance. So this one I just mentioned here, 5200 sorry 52,000 and plus or minus 10 percentage tolerance. So actually this is the answer here. For better understanding this one, you have to remember this color coding. For understanding this color coding, there are some mimics over here. You can go through on this one mimic coding. See here, this one for understanding this one I just mentioned here, BB Roy of Great Britain has a very good wife. Remember this coding here. Always you just read this one 4 to 5 times, black, brown, red, orange, like this. See, you just go through on this color, you just read it for 4 to 5 times so that you can remember this one. See, only confusion over here is the first two B and this one Britain, only there is a color difference. You just remember here. First you have to start with the black, end up with the white. So black to white you have to remember one. Black and white you just remember here. Black, brown, red, orange, yellow, green, blue, violet, gray, white, and this one gold is little less tolerance, and silver is 10 percentage of tolerance. None in this case, that is colorless. Colorless is 20 percentage tolerance apart from some other color. If they have given in this case, you have to mention this one. This is about the tolerance. Only thing you have to remember this one. The next question here is, no, this time they will ask you only colors. Based on these colors, we have to find out the value of the resistor. See here, the color coded carbon resistance has three bands. They are given three bands. The bands from the left are, left one is from left to right. You have to read this one. See, from left here is blue, yellow, and red, and the resistance is, now in this case, remember this one, the BB Roy formula here. See this one for this case. First one is blue, yellow, and red. See here, blue, yellow, and red. First color, first digit. Second color, second digit. And third color is about a multiplier. See, for this one I just mentioned here. For the first color they have given as blue in this case. See this one blue here is 6000 6 number, only number here is 6. Next one is second color is yellow. See yellow I just mentioned here in this case, second here is yellow, so I just mentioned this one as 4. And a third color here is red you can observe here, red here is 2. That means you can mention this one 10 power 2. See this one here is 10 to the power of 2. And what about the tolerance? Say they didn't give any about the tolerance in this case, that is colorless or no color or nothing has been given. So in this case you just mention here, that is about plus or minus 20, that is about the tolerance. See from this one 6400, that is about the resistance ohm, and the tolerance here is plus or minus 20 percentage. That is the answer in this case. This one they have given the answer A. The next one, some of the similar problems I just give you based on this one, the similar one previous problem you just go through on this. According to this one also will be easy here, and the answer also will be given. You just check it according to that according to that table, that one you just follow. So all the answers has been given, you just check it. Okay, next question here is, say n conducting wire of same dimension but having resistivity. See dimension, all n wire having the same dimension, but resistivity has been varied for n1, n resistors which is having 1 2 3 4 up to n, which are connected in series. All are connected in series, then the equivalent resistance of the combination is. Okay, now in this case already we know this one, resistivity, or even based on the resistivity, what is the resistance over here is, you know this formula here, r equal to rho l by a. Now with the help of this formula here, what are the things is going to change over here is this one, based on this one resistance is going to change. So rho has been going to change. For this one I just mentioned here, when the resistors are connected in series, how you can mention here is, this is about the formula, r is equal to r equivalent equal to r1 plus r2 plus r3 up to rn. This is rn, not r3 here. Okay, now next one, see this one, in this case r equivalent will be equal to, see only changes here is, already they are mentioned here, same dimension in this case, length and area will be the same, only changes here is rho, because they have given the resistivity of this one. So only variation here is rho equivalent, and number of dimension here is n. So what they have given here is nl divided by a. Now in this case you just mention all the cases, that one l by a into 1 2 3 4. So you can mention this one l, yeah, l by a, and 2l by a, 3l by a, like that you can mention this one, all resistivity they have mentioned here. In this case what you are going to have here is r equivalent equal to n plus 1. See this one I just mentioned over here, how you are going to mention this one. See in this case you just mention, in this case 1 plus 2 plus 3 up to n, that formula here is I just mentioned here. So this one here is n is into n plus 1 divided by 2. This is the formula here. Already you know this one, this is the equivalent here is, they have given this value rho equivalent into nl. See this one will be equal to rho equivalent into nl divided by a here. So this one already they have given, this one here is n into n plus 1 by 2, already you are having in this case. See this one I just mentioned here, already you are having here is l by a. For this one l a will be cancelled here, for this one l a will be cancelled, and n will be cancelled here. For this one e equivalent equal to, sorry, rho equivalent will be equal to, so what you are having here is n plus 1 by 2. This is the formula here, and this one hope you know about this one, how we are using this formula. Already you know this one. For the better understanding I just take only these three terms, 1 plus 2 plus 3, this one three terms. If you are going to add 3 plus 2 5, 5 plus 2 is 6 here. Now you just going to substitute this one in this formula. So n here is 3 is there, so 3 into 3 plus 1 divided by 2. See this one here is 4 into this one, 3 plus 1 is 4, 4 into 3 is 12, 12 divided by 2 is 6. See both are same in this concept. If n number you are going to add, you are going to use this formula. In this way the final answer what you are going to have here is n plus 1 by 2. So option here is B. The next question here is three resistance 4 ohm, 6 ohm, and 10 ohm are connected in parallel. Remember this one, they have given this one is parallel, and potential difference they have given 330 volt is applied across the terminal of the combinations. Okay, now the current flowing through 6 ohm resistance is. Now this question is very very simple. It's appear like a little difficult, but it's not much difficult. It's very very easy, but you just go through on this questions. Let me tell you here. Let me draw the diagram for this one. See, this is very simple. Remember this one more point I just tell you here. See, this one first one here is they have given three resistance which are connected in parallel. So I just mentioned here. See, there are three resistance which are connected in parallel. The first one here is 4 ohm, next one is 6 ohm, and the third one is 10 ohm. Okay, now, and this one which has been given to the potential, what they have given here is, in this case I just mentioned here, that is 30 volt potential. Now see, once the resistance are connected in series, what about the current, what about the potential? See, in this case potentials are same and current are different. Remember this one always. In this case, if you remember this one, this is very easy. See, this one electron will be moving towards this direction, so the current will be moving towards this opposite to the direction of the electron flow. So what you are having here is current. Just mentioned here. See, from this point, so for this one, from this junction, Kirchhoff law, hope you remember this one. In Kirchhoff law, according to this junction, the current will be flowing. See, I will be there and it will be exiting in different directions, so current will be vary here. So this one here is I1, and this one here is I2, and this one here is I3. So at the end, what you are getting here is again the same I will come. So what they are asking in this case, I2 value they are asking here. So I2 is equal to what? That's what they are asking. The line, last line, just go through the current flowing through the 6 ohm resistance. 6 ohm resistance they are asking here. So in this case, I just mentioned here, according to Ohm's law, V is equal to I into R. From here, I is equal to, what I'm going to mention here is V divided by R. Already they have given the potential here is 30 volt, and the resistance what they have given here is 6 ohm. So what you are getting, that answer here is 5 ampere. So this is the answer in this case. The next question here is, so this one is similar like a previous one, but they have mentioned there in parallel, but here is in series. See, three resistor 2 ohm, 3 ohm, 5 ohm are connected in series with a potential difference 20 volt. And what they are asking here is potential difference across 5 ohm. See, from this one only they have given the hint. Here is in series potential is differ. In the previous case, in parallel, current is differ. Already they have given the hint over in these questions. Indirectly, you just go through on this one. See, for in case of see, I just mentioned here, in case of series connection. In case of series connection, I is same and V is differ. See, I just mentioned here, I is same, V is differ. Remember this point. See, for this one I just mentioned here, 2 ohm resistance, 3 ohm resistance, and 5 ohm resistance all are connected in series, and which has been connected to the potential I just mentioned here, potential difference of 20 volts. See, this is 20 volt of potential difference, and this one here is 2 ohm, 3 ohm, and 5 ohm. See, in this case, see, I will be the same, and but here the potential difference, see, hope you remember this one, this is V1. From here again this is V2, and this one here is V3. What they are asking here is, what is the potential across 5 ohm, that is V3 they are asking here. See, for this one, to understand V3, if you want to find it according to Ohm's law, V3 here is I into R3. That's all, simple concept. See here, V3 is equal to I into R3. That's our formula here. Now we have to find out what is I. We are not sure about this one. For this one, series connection, that is about equivalent resistance here is 2 plus 3 plus 5. What you are going to have here is 10 ohm. That is about resistance here. From this one, current here is I is equal to V by R, and already they have given potential here is 20, and resistance, equivalent resistance here is 10. So what you are having here is 2 ampere. Now you just go through on this one. From here, V3 is equal to current, already we found 2, and resistance here is 5. So what you are going to have here is 10 volt. That is 10 volt of potential will be um, will be drawn across the resistance V3. So answer here is 10 volt. Okay. Now the next topic of current electricity here is cell. In this one, first one, cell internal resistance of 2.1 volt cell, which gives a current of zero point 0.2 ampere through a resistance of 10 ohm. So what they have given in this case, see, uh, 2.1 volt potential has been given. It produces a current of zero point 0.2 ampere when it passes through the resistance of 10 ohm. Now, in this case, what they are asking in this question, see this one, you just um, from here to here you just avoid it and you just read this one remaining thing. The internal resistance is, so the questions here is what they are asking, internal resistance. One way you can understand in this one, this cut point here is, this is about the connecting words to fulfill the sentence here, or else another one, you just go through on the options what they have given, all the things they have given in home, so that you can easily understand what they are asking. Now for this one I just mentioned here, first case, what they are asking in this one, the internal resistance of 2.1 volt cell. Now let me tell you here, this is about a 2.1 volt cell I just mentioned here. This is 2.1 volt of battery here, which produce a current of 0.2 ampere current whenever it passing through the 10 ohm of resistance. When it passing through the 10 ohm of resistance, it produces zero point 0.2 ampere of current for this one. So what they are asking here is internal resistance. Internal resistance in this case, internal resistance of your battery. So this one, this battery which is having an internal resistance small r. See this R and this one capital R, both are connected in series. See, according to Ohm's law, V is equal to IR. See, from this one, what I'm going to replace here is, instead of capital R, this R. See this one and this one, both are connected in series, so all both the resistance are connected in series. This is the formula here. See, from this one we are going to find out what is smaller. See, from this one, V I just going to take over here. See, this one, V divided by E is equal to R plus smaller. See, from this one, smaller is equal to, so see here is V divided by E minus of capital R, that is about internal resistance. Now you have to substitute all the values here. I just mentioned this one. Potential here is 2.1 volt of potential, and next one what they have given, the current value here is 0.2 and minus of resistance 10 ohm. See, from this one, 2.1, what I'm going to mention here is 2.1 divided by see this one, you just multiply 10 by 10. So if you cancel this one, 10 by 10 means that is 1, so that it will be easy for you. See, minus of this one, 10 ohm of a resistance capital R. See, from here what you're having here is 21 divided by 2 minus of 10.5. See, 21 divided by 2 here is sorry, this is 10, I'm sorry. This one what you have given here is, in this case, now this one is 10, and minus of this one, what you are going to have here is 21 divided by 2 here is 10.5 minus 10. So what you are going to have here is 0.5 ohm. That is about internal resistance. The answer here is zero point 0.5 ohm. The next question here is, the EMF of Daniel cell is 1.08 volt when the terminal of the cells are connected to the resistance. Now, the terminal of the cells has been connected to the resistance of 3 ohm. Next, the potential difference across the terminal is found to be zero point 0.6 volt. Remember this one, for a 3 ohm resistance, the potential difference across this one is zero point 0.6 volt. What they are asking in this case, the internal resistance of this Daniel cells. That's what they are going to ask. See, for this one, I have some ideas. I just tell you this one, you just follow it. Okay, now first one, let me tell you here. Suppose we just consider about a two resistor R1 and R2. I just mentioned here R1 and R2, which are connected in series. Now, see, if it is connected in series with the potential of battery here, I just mentioned as this is V here. Okay, now in this case, if two resistors are connected in series, what about the potential and what about the current? You just tell me this one. The potential here is, the potential will be differ, but the current in this case, the current will be same. Now you just have an idea of this one. See, in this case, here is the potential of, across V1 I just mentioned as across R1 here is I just mentioned as V1. The potential difference across R2 here is V2. So this is about the concept. In this case, the potential V is equal to V1 plus V2. This is a basic idea. And the resistance even R is equal to R1 plus R2. Hope you remember, according to that Ohm's law, V is proportional to R. So V is equal to IR. The same concept, these two will work over here. Now we'll go to the questions. The Daniel cell I just mentioned here. This is about the Daniel cell, which is having the potential here is 1.08 volt. Now this Daniel cell is connected to a resistance. Now that one is 3 ohm resistance. So this is about 3 ohm resistance here. The potential difference across the terminal, now this has been connected to, I just mentioned here another one, the potential difference across these two terminal I just mentioned as this value here is 0.6 volt. Now now another one I just mentioned here. Next one, what they are asking, the internal resistance of the cell. See, for the better understanding, I just mentioned here, internal resistance here is, I just mentioned as R. So use the same situation over here. See, from this one, so the total potential V is equal to the same one, V1 plus V2. That is, V1 here is this one 3 ohm resistance, and V2 here is the potential across this one I just mentioned here. That one will be equal to the total potential 1.08 volt. So this one I just mentioned here, V1 plus V2. In this case, now I just mentioned this one. In this case, V1 plus V2 here is this one is I just mentioned as I into capital R and I into small r. Okay, now this one we are not sure about what is the current flowing towards here. See, here current will be the same. Here whatever the current going to capital R, and whatever the same current will be going to the small r. So we have to find out what is IR. See, this one according to the Ohm's law, V is equal to I into R. From here I is equal to V divided by R. See, use this one in case of V1 potential. What they have given here is V1 potential here is 0.6 volt, and divided by resistance, what they have given, the resistance here is 3. See, from this one what you are getting, the current here is 0.2 volt, sorry, 0.2 ampere current. So what we got here is current is 0.2 ampere. Now you just substitute the value here, 0.2 ampere into, and the potential here is 3 I just mentioned here. So what you are getting, the potential difference is zero point 0.6. Similarly, so this one 0.2, the potential across this one, what you have given, the total potential I just mentioned here 1.08. Now the potential difference across this one, the total potential they have given here. See, from this one, uh, here is current is zero point 0.2, and resistance only we have to find out here. So that I just mentioned here, internal resistance smaller. See, 1.08, 1.08 minus of this one 0.6, that one will be equal to 0.2, 0.2 into smaller here. See, from this one, smaller is equal to 1.08 minus a zero point 0.6 is um, 0.48 here, and divided by zero point 0.2, I just mentioned this one. Zero point 0.2, if you are going to cancel this one, see, similarly I just mentioned here, you just multiply and divided by 10 over here, that is 4.8 divided by 2 will be there. So what you are going to have here is 2.4 ohm. That is about internal resistance. Hope you can understand this one. See, a simple concept based on this one, what you are getting, that answer here is 2.4 ohm. Next question. I just tell you easiest way, you just concentrate this one. A student is asked to connect four cells of EMF. See, there are four batteries which is having a potential. EMF means potential 1 volt, and its each cell is having internal resistance here is zero point 0.4 ohm, is in series with the external resistance. One more resistance which has been connected to the battery of 1 ohm resistance, but one cell is wrongly, see, there are four cells, one cell is wrongly connected by him with an terminal is reverse. So the current in the circuit is, see what they are asking in this one, what is the current in the circuit. See, let me draw a small diagram so that you can understand here. See, the first one I just mentioned here, the first battery and second battery, third and fourth one. See here, four batteries are connected in series. See, each is having a EMF potential here is V is equal to 1 volt. I just mentioned here for all the batteries. See, this one plus minus all the batteries which is having 1 volt potential, and each is having a resistance. I just mentioned here, resistance R is equal to 0.5 ohm, and what they have given here is all these are connected and in series with the external resistance. See, I just mentioned here, this one connected in series with the external resistance, that one I just mentioned here, external resistance, that for resistance value here is 1 ohm. So this one I just going to connect so that the circuit will be fulfilled over here. Just a minute. This one I just mentioned here. uh, Now see here, this one you are going to connect with this, right? Now see here. So what they are asking in this one, but one cell is wrongly connected by him, by terminal is reverse. See, plus minus, instead of that one they have reversed this one, minus and plus. See here, in this case, what is the current in this case? Now first we just find the potential here. E or even V will be equal to E or EMF means E you just mentioned here. All this case V1 plus V2 plus V3 and plus V4. So here is the potential is reverse, so that I just mentioned here, this is minus. Now all the potential I just mentioned here. So this one 1 volt plus 1 volt plus 1, and this one is minus 1 volt. So what you are getting here is these two will be cancelled here. So the total potential across here is 2 volt. So I just mentioned here V is equal to, or even E is equal to 2 volt potential. Now all the resistors are connected in series. So internal resistance of all batteries which are connected in series I just mentioned here. So this one is zero point 0.5 plus 0.5 plus again 0.5 and 4 batteries. So the total here is total resistance here is 2 ohm resistance. Now this resistance which are connected in series with the external resistance, so I just mentioned here R plus R, that is 2 plus that external resistance resistance value here is 1. So total what you are having here is 3 ohm resistance. See, from here this one is 3 ohm resistance and 2 ohm potential. So according to Ohm's law you just mentioned here, V is equal to I into R. See, from this one what we have to find out here is I is equal to V divided by R. The total potential here is 2 and the total resistance what we got here is 3. So what you are getting, that answer here is 2 by 3 ampere. The next question here is a cell E1 of EMF. C, for this one EMF is 6 volt and internal resistance here is 2 ohm, is connected with another cell of EMF E2 of EMF 4 volt and internal resistance here is 8 ohm. What they are asking in this one, the potential difference across S and Y. See, only these two they are asking the potential difference. See, don't complicate it yourself in this one. I just give you some theoretical related to this one. You just go through on this. See here, if two cells of EMF are in series, see here, see battery E1 is towards this direction plus negative, but it has been reversed. But if it is the same direction, in this case plus minus, not reversed over here, for this one potential will be the total potential, see V1 and this is V2, the total potential is V1 plus V2. Similar like this, both are connected in series. Similar concept here also, the same resistance here is R1 and R2. R resistance and potential both are act the same in series and parallel connection because V is proportional to R according to Ohm's law. And next one, this is about the formula here to find out the current across this one. And this one, total potential difference across E1, this is about the formula, remember here, E1 minus IR1, that is about the potential. See, this is about the battery potential and this is about the total potential difference. V1 plus IR1 is equal to, this is about the battery EMF E1, this is the concept. But here this case E2 also, that is a total potential across second cell here is V2 is equal to similar concept what I told this one. Suppose the next case, if this battery has been reversed. So this one in this case, how it will work? See here, this battery has been reversed over here. For this one, see here, E1 minus E2, this is about the potential, but the resistance will be in series. See, this is potential has been reversed, similar like this concept. See, this diagram and this diagram, you just go through on this one, and a small change is only on this one only is going to change on the formula. See, first cell discharging, here is discharging, and the second cell is charging. So what they are asking in this case, remember this two formulas, even they may ask you for this one E1, they may ask you for this one, and previous problem, previous formula what I told you, just go through on this one. This formula you just remember, you can easily find out the answer. See, for this one, x and y, that is about E2 they are asking here. V2 is equal to E2 plus IR2. You just go through on this one. Let me explain the concepts over here. For this one, first one, in this case, I just going to find out what is the current across E2 here. See, this one, current I is equal to V by R. That is about the concept here. So the total potential here is 6 minus 4. This is about the potential. Both are reverse. See, this is charging and this is charging. This is discharging here. So 6 minus 4 divided by the uh, the resistance, total resistance, both are connected in series. This one, hope you remember here. See, from this one, 6 minus 4 divided by 10, what you are getting, that one is about current. See, next one in this case, let me tell you here, the second cell is going to charging. For this one, V is equal to E2 minus IR2. See here, V2 is equal to, I just mentioned here from this one here, V2 is equal to, V2 is equal to E2 potential here is 4 volt plus I1 already we are found out the value 1 by 5, that one into resistance here is 8 ohm resistance. See, from this one you just mentioned here 4 plus 8 by 5. This one I just simplify here as 28 divided by 5. So what you are getting, that potential across x and y here is 28 divided by 5. I just mentioned here 5.6 ohm. So that answer in this case here is, I'm sorry, this is not a ohm. You are going to find out the potential. So that answer here is 5.6 volt. I'm sorry, 5.6 volt. Okay, next question here is, two cells of EMF E1 and E2 are connected in series in a circuit. So in the circuit, both the cells are connected over here, and both the cells which is having internal resistance R1 and R2. Then the total current they are asking about I is what? That's what we have to find out here. See, for this one already I told, here cells are connected in series, so that potential here is, I just mentioned here, E is equal to, I just mentioned here, E is equal to E1 plus E2, or even potential in this case, V is equal to V1 plus V2. See, from here, according to Ohm's law, E is equal to, or even V is equal to I into R. See, for this one, what they have given in this case here is, see, I just mentioned here. So this one here in this case I just mentioned here, E1 is equal to the same one, E1 is equal to, current will be the same, only the potential will be different. So I into, here internal resistance here is R1. Similarly E2 is equal to I into R2. Now in this case E is equal to E1 plus E2. You just substitute the value here, I R1 plus I R2 here. Now from this one, the common one I will take it out. So R1 plus R2, that one will be equal to this one here is E value I just mentioned here. E is nothing but E1 plus E2 here. So E1 plus E2. From this one, I is equal to, from here I is equal to E1 plus E2 divided by R1 plus R2. So answer here is this one. Okay. The next question here is, a battery is charged at a potential of 15 volt for 8 hours. First, initially it has been charging with the potential of 15 volt for 8 hours. So here the current flow in this case here is 10 ampere of current flow. Next one, the battery is now discharging and it supplies 5 ampere of current for 15 hours. See, this is 15 hours 15 volt 8 hours. Here is 5 ampere, but here is 10 ampere current. Here is 5 ampere current for 15 hours. What they are asking, the mean terminal voltage during discharge is 14 volt. So this one 15 volt, and during discharge the value here is 14 volt. What they are asking, what are energy efficiency? So they are asking about efficiency. Before going to that, let me tell you. See, efficiency in this case, you can understand this one, energy consumption. See, in this case, how you can measure the power, how you can measure this one here is power P is equal to, even you can mention this one, power P here is the amount of energy utilized here. That is amount of energy in this case, what we can mention here, watt per time is called as power. See, from this one, see from here, I just mentioned the same, W is equal to power into time. Already we know this one, power is equal to voltage into current. Now this one utilized from here during charging. See, I just mentioned this one, during charging. In this case, consumption here is W is equal to VIT. See this one, you just substitute this value, W is equal to VI into T. So substitute this value, 15 volt of 15 voltage of 10 ampere current for 8 hours. What you are getting here is energy during charging here is 1200. During discharge, see here the same one, 14 volt has been discharged over here for this one, the same 5 ampere of current for 15 hours. So here power here is 1050. This one, the similar in this case, efficiency, how you can find out the efficiency here is, you can find out the efficiency by output divided by input. See, total output, total discharge divided by total charging. So this one output here is 1050 divided by 1200 into, you just mentioned here 100 percentage. See this one I just mentioned here 100 percentage, the same concept you can get this one. From this one what you are getting, that value here is 87.5. The next question here is, in the circuit shown, see here in the circuit shown, P is not equal to R, that is P resistance is not equal to R resistance. The reading in the galvanometer is same. See, P and Q are, P and R are differ, and the galvanometer is same even when the switch S is open or closed. See, hope you remember in this case. See here, in this case, in the Wheatstone bridge, actually what's the formula in this case of Wheatstone bridges? I just mentioned here, P by Q, that one will be equal to R divided by S. So in this case I just mentioned here, see in this case I just mentioned here, if Weinstein bridge is balanced, in that conditions only we are going to have this one. See, at the same time in this case what they have mentioned here is P is not equal to R. Now in this one you can understand better here. Suppose as there is no change in this one, as there is no change in the reading of galvanometer when the switch S is open and closed. In this case, what they have mentioned here is the bridge is balanced. So this concept will work over here. In this case, if IR equal to C, this one, the current flowing across C, this one IR will be equal to IG. That means both are connected in series, and the current flowing to IP and IQ will be the same because these two are in series, and this series both are connected in parallel condition. So if it is in a parallel condition, the current across this one and this one will be vary. So what you are having here is current is differ in this case, and this one also will be differ. That's what they have given, P is not equal to R. See, from this condition these two will be the answer. From this one, if they have given the answer, you can utilize that one as an option. Okay, next one is, two electrical resistors have equal value of resistance. See, remember, this is the highlight point, you just remember here. uh, Two electrical resistance have equal values of resistance. Resistance are equal. Each can be operated with a power of 320 watts at 220 volt. See, 220 volt with 320 watts of power. See, potential here is 220. Each resistors are operated over here. And see here, if two resistors are connected in series, additional what they have given here is, see, two resistance has been connected in series to 110 volt electrical supply. Series with C here, 110 volt. Actually it can be operated with a 220 volt, but it has been connected to only 110 volt. Then the power generated in each case, that's what they are going to ask in this case. Now in this case you just go through on this one. The first here is, if the resistance of resistor, see resistance of resistor what you have given here is R equal to V square divided by P. See already you know this one according to Ohm's law I just mentioned here. According to Ohm's law, V is equal to I into R. From here, from this one I just mentioned here, I is equal to V divided by R. And next one R else, even you just mentioned from this one, R is equal to V divided by I. Already you know this one, power value V is equal to V into I. See from here, instead of I, what I'm going to mention here is I is equal to P divided by V. From this equation you just substitute the value here. So R is equal to V divided by P whole divided by V. So what you are going to have here is V square divided by V, that is nothing but equal to the resistance. So from this one you just substitute here, which is going to operate with a 320 volt. So we're just going to mention 220 volt, and the power here is 320. So this is about the resistance. And next condition what they have given in this case, when these are connected in series. Okay, now remember this one. See from Ohm's law only you can understand here. See V is proportional to R. Once R is connected in series, R equal to R1 plus R2. Similar concept over here. Voltage across each other connected in series. So from this one, R1 plus R2 or even V1 plus V2 here is, see I just mentioned here, V1 plus V2. That one they have given 110 volt. V1 plus V2, from this one, equivalent resistance here is 2V. From here, what you are going to have, V both are connected in series. From this one, V is equal to, V is equal to, I'm sorry, 110 divided by 2, what you are going to have here is 55 volt. Now power generated here is P is equal to, the similar concept, P is equal to, from this one, from here, see from this one you can understand here, P is equal to, you can mention this one, P is equal to V square by R. Substitute the value of V from this equation, you can get here. Now substitute the value in this case. So from here V square value here, and even R you just find out from this one. Substitute the value. Say 55 square you can mention like 55 into 55 and divided by 220 into 220, and 320 will come here. So 55 by 220 here is 4, and again one more 55 by 220 here is 4. 4 into 4, 4 square, and 320 divided by 4 square, if you divide this one, what you are getting, that answer here is 20 watts. Next question of this topic here is heat production in a conductor of resistance. Conductor having a resistance of 4.2 ohm with a 10 ampere current is, so what they have given here is, in this case, calories per second. Now this one heat production, what we are getting that here is heat production, in this case heat energy. Now this one, in that one I just mentioned here, according to Joule's law of heating. What I'm going to mention here is, according to Joule's law of heating, H is equal to I square H is equal to I square R into T, where already they are given this one heat production per second. So I just mentioned in this one. So H divided by time, that is H is nothing but heat production here, heat production per second, that is about the time. What I'm going to have here is I square into R. So already you know this one, here is I value what they have given, the current here is 10 square here, into R value here is 4.2. So heat production in this case what you are going to have here is 420 joules. That is about heat productions per unit time. That one, heat production per time. See this one, according to this one, 1 calories. See one, one calories here is 4.2 joules. This is the general unit. From this one, 1 joule here is 1 divided by 4.2 calories. See what you are going to have, the heat production which is in joules, but they have given the answer is in heat production in calories. So I just mentioned here 420 into, instead of 1 joule, so instead of this one 1 joule, I just going to have here is 1 by 4.2. See this one, 1 divided by 4.2 into calories. Already you are having, this one is calorie per second. So calories per second here. See from this one, if you are going to mention here is, if you cancel this one by here is, what you are going to have here is 100 times. So what you are going to have here is 100 calories per second. So answer here is, the next question here is, a resistance of coil of 60 ohm. So what they have given, the resistance here is 60 ohm, which is immersed in 42 kg kilogram of water. See, yeah, just a coil. This is like this one geyser, or even electrical geyser. What we are using here is for heating the water. This one for getting the hot waters, how we are using the similar concept here. A coil which is having a resistance of 60 ohm and immersed in 42 kg of water, a current of 7 ampere is passed through it. The rise in temperature in the water, that's what they are asking here. See, 60 ohm of resistance wire which has been placed in a water, rise in temperature. See, this one according to Joule's law of heating. This one, see, energy released here in this case, what you are going to have here is E is equal to I square RT. Now, this is the formula where we are going to have the amount of energy is released. See, this energy has been released when a current passing through the coil. Okay, now this energy, how much it has been absorbed, energy absorbed by the water here is the energy gain. This one, gaining energy here is Q is equal to ms into delta t. See, this one, Q is equal to ms into delta t here. And from this one, you just substitute all the values. See, energy gain, heat gain here is, this is about the energy, and this is about energy release. This is going to observe. See, from this one we have to mention about a mass of the water and specific heat capacity of the water. From this one, how much amount of heat that can be raised in a water. So from this one, del T here is, del T is equal to Q divided by ms. Should see, Q divided by ms. Q is nothing but I square. That is about the energy released here. This one, energy is gained. So how much energy has been released? This one is energy is gained per minute. So that's what they are asking here, energy released per minute. So from this one, instead of Q, I just mentioned here I square RT here. I is about the current 7 square. R here is 60 ohm of resistance here. And the time here is per minute, means 1 minute 60 seconds, divided by mass here is 42 kg, and specific capacity of water. This one you have to remember, that is 4200. See, from this one, see, from here I just mentioned this one. See, this 2 cyber will be cancelled here from this one. And this one here is 7 square, 1 7 into 6, that is 42. 1 will be cancelled, another 1 7, another 1 6 here, so that will be cancelled, another 42. So what you are going to have here is 1 degree Celsius. A simple 1 degree Celsius per minute it will increase. So for, if you want a 40 degree Celsius, means it should run for 40 minutes. Suppose if you want to 60 degree, too hot water, suppose if it is in a boiling water, in this case you have to increase, you have to give this one for 100 minutes, that is one and a more than 1.5 hours if you are giving, so that you can get the hot water. So answer here is 1 degree Celsius. The next question here is, two electric bulb whose resistance are in the ratio of 1 is to 2 are connected in parallel. See, key points we need to remember here is, resistor bulb which is having a resistance are connected in parallel. Parallel connection, always remember this one, parallel connection, potentials are, that is voltage is same and current is differ. So this one, connected in parallel means voltage is same, constant, current is differ. To a source of constant, see, already they have given a source of constant voltage. What will be the ratio of power dissipation in this wire? See, power dissipation in this wire, how you are going to find out here is, see, this one, the simple formula, power P is equal to V square by R. And V, already we mentioned this one, V is constant, and P is inversely proportional to R. I just tell you how you are getting this one. See, in this case, power P is equal to, already you know this one, power P here is, P is equal to voltage into current. According to Ohm's law, V is equal to I into R. And this one, from here, current I just mentioned here, V divided by R. From this one, you just substitute here, instead of I, you just mention here V into V divided by R. So what you are going to have here is V squared divided by R. See, from this one, V is constant, P is inversely proportional to R. For this one, P1 will be equal to constant into R1. Similarly, P2 is equal to constant into R2. P1 by P2 here is inversely proportional. So what you are going to have here is R2 by R1. Already they have given the resistance here is 1 is to 2. So R2 by R1 here is 2 is to 1. So the answer in this case 2 is to 1. Next question here is, which of the four resistance P, Q, R and S generates greatest amount of heat when current flows from A to B? The current flowing from A to B, see in this case you just remember here. See, in this one, P and Q are connected in series. In this case, the potential difference across P and Q only varies. And at the same time, P and Q are connected in series. In this case, the equivalent resistance here is P plus Q. Similar here is R plus S. But this PQ and RS are connected in parallel. In this case, both are connected in parallel. Parallel connection, current is differ, but potential voltage is same. So now this one, in this case, you just have an idea for this one. R1 I just mentioned here. R1 is equal to, both are connected in series. That one P plus Q. 4 plus 2 here is what you are going to have, 6 ohm. 6 ohm this combination, and this one here is R plus S. You are having 3 ohm is the combination. This 6 ohm and 3 ohm are connected in parallel. See, once it is connected in parallel, already you know this one, potentials are same. So I just mentioned here, the potential V1 will be equal to V2. Already according to Ohm's law, V is equal to I into R. See, already they have mentioned here, V1 here is I1 R1. In this case, V2 here is V1 equal to I1 R1, V2 here is I2 R2. See, from this one, I1 here is R2 by R1 into I2 here. R1, R2 values you found from here, you just substitute here from this one. I2 and I1 relation here is I2 equal to 2 times of I1. See, if it is I1, this case, here is I2. Twice the amount current will move towards here. See this one, heat energy, already you know this one, H is equal to heat flow here is I square R into T. See here, there is a less amount of, see from this one, less amount of resistance. Resistance is less means it allows more amount of current. If current is more means heat production will be more. So from this one you can understand directly. So the current flow will be maximum from this combination. This is C. In this case, see this one I just mentioned here. And in this case, this one here is, this is current flow I here, and this one I just mentioned here I1, and this one I just mentioned as, this one here is I2. See, already they have given I2 here is 2 times of I1. So this one, how much, say for example here is 10 ampere current is flowing here is, here you are having 20 ampere of current. For example I am telling here. So similar, according to this concept, this side current flow will be maximum. To confirm that, for Q, if the current is moving and moving away from here is, heat energy here is I square R into T. I square here is I1 current will flow over here. Here resistance R here is 4 ohm. So they have mentioned here I square value here is from this one, I2 divided by 2. So whole square here is I2 square divided by 4. So what you are going to have, 4 will be cancelled here, I2 square into T. For in this case, if the current flowing towards here is the same one, you just substitute the value here is what you are getting, 2 I2 square. Already I told this one, this is twice the amount. So the current flow, if current flow is maximum here, greatest amount of heat energy that can be generated towards yes also maximum. Say from this one, which resistance produce more heat energy here is yes. Next question here is, what is the ratio of heat generated in R and 2R? So heat generated in R and 2R, both the resistance are connected in parallel. So parallel in this case, current is differ, potential will be the same. See, according to this one, first I just mentioned here, heat generated in case of, first one is R I just mentioned here. For this one I just mentioned here, for in this case, R heat generated here is, I just mentioned here, H1 equal to I square R into T. So this is T is nothing but that timing here, I square RT. And from this one, according to Ohm's law, V is equal to I into R. See, from this one, I is equal to V divided by R. Substitute this value here. Instead of I square, you are going to substitute here V square divided by R into RT. right? And for this one, resistance here is R, so I just mentioned as resistance here is R. So only thing is what you are going to have here is, so V by R, what you are going to have here is this one, V square by R square. So 1 R will be cancelled. So what you are going to have here is V square divided by R into T. For in case of 2R, I just mentioned here, in case of 2R, what you are going to have here is that one I just mentioned here, heat generated here is H2. The same one I square R into T here. The same one from here, what you are going to have here is V square divided by R square here. R here is 2R square into 2R into T. See from this one, 2R, 2R will be cancelled here. So what you are going to have here is V square divided by 2R into T here. See from this one, what they are asking, the ratio of, see simple, I just mentioned here, R by 2R or even H1 by H2, heat production of, yeah, R and 2R here. See this one I just mentioned here, V square divided by R into T divided by V square whole divided by 2R into T. So T will be cancelled here, V square will be cancelled, and even R and R will be cancelled here. See from this one, what you are going to have, this denominator will come over here, that is 2 divided by 1. So what you are getting, that answer here is 2 is to 1. Next question here is, a 5 degree Celsius rise in temperature is observed in a conductor by passing some current. See, you just consider a wire or a conductor. In a conductor, when you are passing a current, it produces 5 degree Celsius temperature. That is, the conductor is getting heated 5 degree Celsius. Now, what you are going to do here is, when the current is doubled, once you are going to increase the current twice the amount, then what is going to happen here is the rising temperature will be equal to, now twice the amount, what is the temperature has been increased. See, temperature increase here is the amount of heat energy is produced. According to this one, heat energy produced here is Q is equal to ms into delta T. Already you know this one, gain in heat temperature here is, according to Joule's law of heating, heat energy raised here is I square R into T. That one will be equal to ms into delta T. Only thing is current is going to increase, and remaining one, delta T, that is rise in temperature. These two are related one. Remaining thing they didn't mention about this one. That one we consider it as an constant. So from this one, I square is directly proportional to T. In the first case, I1 equal to, you just mention as I1, and I2 here is I1 equal to I, and the next case I2 here is twice the amount, that is 2I. Now take a ratio of this one. I1 square is directly proportional to delta T1, and I2 square is directly proportional to delta T2, and proportionality constant will be cancelled, both are similar one. So I2 divided by I1 here is delta T2 divided by delta T1, and I2 here is 2I. 2I means 2I square, that is 4I square will be there, divided by I1 here is I square will be there. So from this one, I square will be cancelled here. This will become 2 square. 2 square here is 4. So 2 into 2 square into 5 here is 4 into 5, that is 20. So the answer here is 20 degrees Celsius. Next question here is, three resistors of equal values are arranged in four different configurations as shown in the figure. Power dissipation in the increasing order. Increasing order in this case, from the small value to large value we have to mention. See for this one, for example, see in this case, first one, all three resistors are connected in series. See for that, what I'm going to mention here is all are connected in series. So this one, the equivalent resistance here is R1 plus R2 plus R3, or even R plus R plus R. So what you are going to have here is 3R. That is about the answer in this case. Next one, in this case, see two resistors are in this one connected in series. So this one here is, I just mentioned as, this one is 2R here, and this one is R. So this one, both this one are connected in parallel. So 1 by RP it will be equal to, now I just mentioned here, 1 divided by 2R plus 1 divided by R. So what you are going to have here is, I just take 2R here. So 1 plus 2 here. So 3 divided by 2R. So what you are going to have in this case, so this one here is RP here is 2R divided by 3. So this one I just mentioned here. Equivalent resistance here is 2R by 3. Here is 3R. This one R plus R. This one R, 3R are connected in parallel in this case. See 1 by R plus 1 by R. See this one how I am mentioning here is, in this case all the r's are connected in parallel, so 1 by r plus 1 by r plus 1 by r, so r is common, so 3 by r, so the resultant or even equivalent resistance I just mentioned here is this one here is r divided by 3. Now, in this case, in the next case, these two are connected in parallel. So here is equivalent resistance is R by 2. This R by 2 is connected in series with this one. So I just mentioned here in this case. So here is R divided by 2 plus R. So what you are going to have here is 3R divided by 2. See, for this one increasing order, in this case the last one should be maximum, and first one should be minimum. See, last one should be maximum, first one should be minimum here. For this one 3R, this is 3R, so I just mentioned here 3R is the last one. Next one, in this case you just mentioned here 2 by 3 here is 0.6, and 3 by 2 is 1.5, and R by 3 here is zero point 0.3. See, this is 0.6, zero point 0.3, this is 1.5, this is 3. So I just mentioned here first one here is in this case I just mentioned here, um, 3, first one here is 3, 3r will be there, next one is 1.5, and the next one is 0 0.6, and next one is 0 0.3. 0 0.3 here is the third one, and a zero point 0.6 here is second one, and 1.5 here is a fourth one, and 3 here is first one. So answer in this case. The next topic from this chapter, current electricity, here is Kirchhoff's law, Wheatstone bridge, and meter bridge. Okay, now coming to the question, the value of I in the figure will be we have to find out what is the current in this case. See, for this one, let me tell you, according to Kirchhoff law, see, the current entering inside will be equal to, see, I just mentioned here, current entering inside will be equal to current inside, I just mentioned here, and the current exiting out. So I just mentioned here current which will be exiting out outside. So that's what according to Kirchhoff law. See, for this one, you just go through on the first side over here. See, 10 ampere of current on this junction I just mentioned, in this case 10 ampere of current. From 10 ampere, 6 ampere is going out along this side. So the next one here is I just mentioned in this case, what is the remaining current here is, in this case 10 minus 6, what you are going to have here is 4. 4 ampere of current is moving towards this junction. In this junction you are having 4 ampere of current. Additionally, 1 ampere of current, in this case it is entering here, and this one, from this one, what amount of current that is exiting out here is 5 ampere of current. Now next one, you just go through on this junction here, 2 ampere of current. In this case 6 ampere is entering towards here, and 2 ampere is entering towards here, both combined together 8 ampere is exiting out. See, from this one, how much amount of the current which is exiting over here is 6 plus 2, that is about 8 ampere of current. Then coming towards this junction from here, I is exiting out, that one will be equal to current entering here is 5 plus 8. So what you are going to have here is 13 ampere of current. So answer in this case 13 ampere. Now next question here is find E in this diagram for the given loop according to Kirchhoff voltage law. This is about the Kirchhoff voltage law, or even loop law. In this one, how you are going to find out E value in this case. If you want to understand this one better, you just go through on this rule, Kirchhoff rule for your Kirchhoff voltage law. See, for this case, suppose, see here, this is about clockwise direction. Suppose if you are going to find out voltage value in clockwise direction, see, use this one, this clockwise direction you just utilize here. For clockwise, see, this is about the direction of travel, this is about the clockwise direction, so I just mentioned in this case. See, if you are crossing the resistor in this case in a clockwise direction, the current flow, see here, current flow direction only you are going to measure in this case. There in the resistor, the value here is minus IR. So here the potential across the resistor here is negative value you should consider. Next one, suppose in case of battery, see negative to positive, if in the direction of current, the same one direction of travel, if the direction of travel it's moving from negative to positive, you always mention as positive potential. Suppose here in this case, see this is about the direction you are going to measure. This is positive to negative. Positive to negative means you have to mention this one is minus 10 volt. The next case, this is anti-clockwise direction. The similar concept I'll tell you. See, this is anti-clockwise direction. Here you are going to measure in this direction. See, in this way, if you are going to measure in this case, see in this one, this is the direction of current, but you are going to measure opposite to the direction. If you are measuring in this case, if see this is direction of current flowing towards this direction, but you are going to measure along anti-clockwise direction. In this way, if you are going to measure the resistor value, it should be positive. Remember here, this should be positive. And if it is a battery, in this case the same way, see you are going to measure in negative to positive, so that you are going to measure the potential values, it should be negative. See, I just show you how you have to understand with the values. You can understand over here. First we are going to start clockwise direction. In this way you just find out over here. In this way you are going to find going to measure the potential. In this case, first one 3 ohm along this direction we are going to measure 3 ohm. In this case, see here 3 ohm, 3 ohm resistor current is moving towards this direction. So in this direction you are going to use this one. Direction of travel here is clockwise direction. Once you are crossing this one, here the potential here is minus of IR, that is current here is 1 ampere, resistance here is 3 ohm. So what you are going to have here is minus, I just mentioned here, minus 3. Am I clear? Okay, now next one, coming to battery here. Now once you're going to coming to battery here, see positive to negative, but here this is the direction of travel. See, direction of travel here is clockwise, so that we are going to use, see direction of travel here is negative to positive means positive, but positive to negative, in this case you have to mention this one, that is negative value. So I just mentioned here negative minus 10 volt. I just mentioned here minus 10 volt. Now next one, coming to here 5 volt, this is again negative to positive. The same concept of 5 volt here. See, 5 volt negative to positive, negative to positive means you have to mention as 10. See this one I just mentioned here, this is 10 volt. I just remove this one, minus 10 only. And next one, in this case minus this one here is plus 5. I just mentioned here, this is about plus 5 volt. Then coming to the resistor towards the direction of the current, same concept. See here, this is 6 ohm. You are going to follow this one only. See, towards the direction of the current, see you can understand here direction of the current. Towards the direction of current, here is minus IR. Current here is 1 ampere current. Resistance here is 6. So what you are going to have here is this one here is, I just mentioned here, this is minus 6. Okay, next one, coming to the third side again the same direction. And direction here is the current direction only you are going to measure. Here is 4 into 1, that is minus 4, you are going to measure as minus IR. Then E, here is E potential, minus to positive. Here minus to positive means you have to mention the potential is plus. Now second diagram you just go to here, that one will be equal to 0. See, from this one, this value here is minus 10 here, and this one is plus 5, and this one is minus 13. So, and even this one what you are going to have here is E. See, from this one what you are going to have here is minus 23 plus 5 plus E will be equal to 0. See, from this one what you are going to have here is minus 18 plus E will be equal to 0. See, from this one again I just mentioned here, E is equal to plus 18. Remember this one. So the answer in this case here is 18. Okay, now the next one I just show you. See, till now we have seen about clockwise direction. The same one I just show you in the anti-clockwise direction. See, everything you just consider here. Now first we have seen in clockwise direction. Now we are going to find out in anti-clockwise direction. In this way you are going to measure. See, from this one I just going to start from E. For the hint I just mentioned here, you are going to use this one. Remember here. See, first one you are going to start from here. This is E. E means this is about battery. Battery means battery anti-clockwise direction. You just mentioned here. See, this is current direction. See, direction of travel here. See, direction of travel, you are going to travel in this way. Positive to negative means direction of travel, positive to negative means that is minus. So you just mention here, this one here is minus E. Now I just mention here, this one here in this case minus E here. Next one, and this is direction of current. See, opposite to the direction of current you are going to measure here is plus IR. So what you are going to have here is R here is 4, current here is 1. So I just mentioned in this case this one here is plus 4 into 1 plus 4. Next, coming to B to C direction. B to C direction, again the same. This is plus 6 here. You just follow this one. See, again I just tell you in this way. Current direction, opposite to the direction of current, you are going to measure. So in the resistor, that value is plus IR. So R here is 6, current here is 1 ampere. Opposite to the direction, you are going to measure in this direction. Current direction, opposite to the direction of current, you are going to measure. So plus IR will be there. R is 6, I will be 1. So what you are going to have here is plus 6. Next, coming to here, this is battery. Battery means coming to here, positive to negative in this case. See, positive to negative direction only you are going to measure. So here is negative. So what you are going to mention here is this is minus 5 will be there. So I just mentioned it, this is minus 5. Okay, now coming to C to D. See, in this case, C to D, see, negative to positive or towards the direction here is direction here. Positive to negative direction means negative, but here is negative to positive. You have to mention this one is plus value. So what you have to mention in this case, this one C here, I just mentioned this is plus 10. Am I clear? Now this one again, here this is 3 ohm resistance. Current direction here is this direction. See here, current direction, opposite direction you are going to measure. So this is plus 1. So plus I just mentioned here, this is plus resistance here is 3 and current here is 1. So 3 into 1 here is 1. That one will be equal to 0. See, this is 13 here and this one here is 10 here. So and here is you are having minus 5. So see, I just mentioned here minus E. 10 plus 13 here is plus 23 minus 5 will be equal to 0. So this one again I just mentioned here minus E plus 18 will be equal to 0. From this one E is equal to 18. In two way you can follow this one. So answer in this case the same one. Even in case of anti-clockwise direction, even in case of clockwise direction also you can mention, you can find out the answer. Okay, next problem here is the potential difference between the points A and B. What they are given here is E and B. What is the potential difference? See, for this one, the similar concept, what we have seen, the similar problem. For that one, I just take this one as an hint. You just remember this one. First, before going to that, you have to decide in which direction. The direction you have to select according to the direction only. You are going to measure the potential across this one. See, if I mention this one is clockwise direction. See, this one here is clockwise direction. The potential at AC here, always remember this point. You just mention this one A and B. You just mention this one as see, in between I just mentioned here the potential here is, you should just simply mention VA minus VB. That is about the potential difference will be equal to 0. You just have an idea of this one. So in between VA and VB, in between VA and VB, we are going to measure according to this one's Kirchhoff law. See here. So in between VA and VB, you have to measure according to, you have to substitute that value based on this one. We have selected here is clockwise direction. Now I just mentioned this one in clockwise direction. First one I just mentioned here. This one here is VA. Okay. Next one. Coming to the voltage. This one battery here. See, this one here is positive. I just mentioned as this is positive, and this one here is negative. See, 6-volt battery, positive to negative, direction is towards this direction, clockwise direction. Now you just go through on this second diagram, clockwise direction. This is positive to negative, but what you have given here is negative to positive, means the potential is positive, but here is positive to negative. Now this one you are going to measure in this way, right? For this one, what you are going to measure here is, this one is, I just mentioned as this is minus 6V potential. Okay, now next one, coming to the resistor. See, coming to the resistor, in this case this is positive and this is negative. Negative means electron will be moving from towards from here. So opposite to the direction current flow will be there. That means you are going to measure opposite to the direction. Now coming to this one here. See, this is towards the direction in the resistor. See, this is direction of the current. This is the direction of measurement what we are doing here. but here is current is moving opposite to the direction because electron is moving from negative terminal to the positive terminal. This one, this side it will come. So current is be moving opposite to the direction. So here is you have to measure, this one is plus. See, in this case they are mentioned as negative. So opposite to the direction is only opposite to the direction of current we are measuring. So this one we call it as positive. So that what I am going to mention here is plus IR. So plus into I value here is, I here is current is 3 ampere and R value here is into 2 ohm. So what you are going to have here is plus 6. Next one, coming to the battery. Battery in this case positive to negative, but you just observe in the second diagram, this is negative to positive, here is positive to negative. So you have to mention this one is negative potential. So you just mention in this case, I just mentioned here battery is -9. Okay, now coming to here, in this case, say little bit it will be confused, but be concentrate here. See, coming to this one, this is about a resistor. Current direction, see here electron will be moving towards here. Already they have mentioned the current will be moving in opposite to the direction. This is positive and this is negative. Current direction is opposite to the direction. See here, this one I just mentioned here, current direction, same direction if you mention, that is negative, but opposite to the direction you just mention as positive. See this one, see this is 3 ohm of resistor, current flow here is 3 ampere of current, 3 into 3, what you are getting here is plus value. This is not negative value, so this is what you are going to have here is plus 9 volt, and at the end you just mention here VB will be equal to 0. This one plus 9 minus 9 will be cancelled here, and 3 into 2, this is plus 6 and this is minus 6, both will be cancelled here. So what you are going to have here is VA minus VB will be equal to 0. So the answer here is 0 volt. Okay, next question you can observe here. See, the network, this is about the network shown the points A, B and C, which are the potentials they have given 70 volt, 0 volt, and this one 10 volt. The potential at D, what they are asking here is potential at D. See this one, if you want to understand this one, you just go through on Kirchhoff current law. See, according to Kirchhoff current law, what you are going to do here is the current entering inside. See, I inside will be equal to, see this one I just mentioned here. I inside will be equal to I entering outside and exiting outside. So this one I just mentioned here. I entering inside. See this one, the current in this junction you just consider here. In this junction, the current entering towards inside will be equal to the current which is exiting out. Now, according to this one, you just follow this one. See, according to KVL, see what you are going to have here is VAD. See, the current entering towards inside here is, according to Ohm's law, you can mention here V is equal to IR, I is equal to V by R. V is about the potential difference on either side of this one. See here, VA minus VD divided by R here is 10. Similar concept here, VD minus VB divided by 20 and VD minus VC divided by 30 here. Now you just simplify this equations. Once you are going to simplify this one, substitute the value of VA and VB. So they have given that value here from this one. You can easily find out. Simplify this equation. You can find that answer here is 40 volt. Now, in this case, the electric current I, see here, electric current I in the given circuit. See, like this circuit, if they have given here is, you just need to follow a Kirchhoff junction law. According to the junction law, when the current moving towards the junction will be equal to the current that is exiting out. See this one, to understand better, I just show you a maximized structure of this one. See, listen here, according to this one, according to Kirchhoff junction law, current inside I just mentioned here, I in will be equal to I outside. So this is the concept here. In this case, now you just follow in this case. In this junction, current here is entering inside and this side also entering here. So both the current are entering here. 2 plus 1, what you are getting here is 3. So while exiting out, so current entering inside here is I1 plus I2. That one here is 2 plus 1, what you are getting here is 3. 3 current are entering towards the junction and exiting, that will be equal to here is exiting, that is 3 ampere of current is exiting over here. So I just mentioned this one here, in this case 3 ampere of current. Now similar concept here. See, in this junction, what I'm going to mention here is 3 ampere of current here is entering here, and from 3 ampere, 1 ampere current is exiting out. So here what you are having here is 3 is here, and here is 1 ampere is exiting out. This one I just mentioned as X. So from this one, X is equal to 3 minus 1, that is 2. So what you are going to have here is 2 ampere of current. Now current in this junction, in this case, current entering inside here is 2 plus 2 here, and exiting current they have given here as I. So from here I is equal to 4 ampere of current. So answer in this case 4 ampere. Now the next question here is, this is about the potentiometer. The EMF of the battery A is balanced by the length 80 centimeter on a potentiometer wire. Now 80 centimeter length for the potentiometer wire. Now the EMF of the standard cell here is 1 volt. It is balanced by 50 centimeter. What they are asking here is EMF of A. So this one is comparison of EMF of the battery by using the potentiometer. See, in this case, this is about the comparison of EMF. That formula here is, you can understand this one in IP. You can go through on this one, E1 divided by E2. So that one will be equal to L1 divided by L2. Now in this case, the potentiometer or even EMF of the battery is directly proportional to the length of the potentiometer. For this case, here the first potential what they are given here is the potentiometer I just mentioned here. For the first one, here is 50 centimeter, that is about the length. So I just mentioned here L1 is length here. For this one, what is the potential they have given here is E1 is equal to 1 volt. Now next one here is for the length L2 here is for the length L2 here is 80 centimeter. Then for this one what they are asking, E2 value is what. Now substitute the value here in this case. Now this one 1 volt battery, in this formula I just mentioned here, E1 divided by E2 will be equal to L1 here is 50 divided by 80 here. This one 0 will be cancelled. From this one I just mentioned here, from here E2 will be equal to, E2 here is 8 divided by 5 into 1 volt. So what you are going to have here is 1.6 volt. This is the answer for this one. 1.6 volt is the answer. Okay, before going to the next problem, let me show you some of the hints over here. The first one is EMF of the cell of the secondary circuit is directly proportional to this one. The last only we have seen is proportional to L. If L1 and L2 are balancing the length of the two cells, then the secondary cell here is E1 by E2 equal to L1 by L2. And next one here is sum and difference method. That means both are connected in series. One has been changed in a reverse order, or that is opposite poles are connected. So like this means, that is about the formula here. See, L1 and L2 are balancing length corresponding to two cells which are connected in secondary circuit. First support each other, then opposite to each other, means this is about the formula here. So E1 plus E2 by E1 minus E2 here is L1 by L2. And the next case E1 by E2, this is a simple cross multiplication. That one I will show you in the next slide. You can see this one how you are going to do. And the next one here is, if L1 is balancing the length of the cell in the secondary circuit, if a no resistance R is connected across the cell, then the balancing length here is, once it has been connected by the resistance, there they are changing the length here is L2. So how we can find out the internal resistance? This is about the formula here. And one more main hint here is L2, which should be less than L1. You remember always this one. Next question on a potentiometer. This one here is the balancing length of the potentiometer wire. Balancing length, first one is 800 centimeter and second one is 600 centimeter. That means that is a 10 lines of wire. That is 10-meter wires will be there. In that one, first balancing here is 800 centimeter, second one is 600 centimeter. When two cells of EMF E1 and E2 are connected in the secondary circuit. Say first one is primary circuit, which is having only the wire, and secondary circuit you are going to have two cells with the EMF E1 and E2 circuit. First in series, both are connected in series. That one is length is L1, that is 800 centimeter. And then the terminal of one cell is reversed. I just show you here. See this one, in this case CD, in this case this is about the 10-meter wire of the lens. In this, the first one, both are connected in series. That one, what you are having, the balancing length here is 800 centimeters. Second one, in this case the terminal has been reversed. Once it has been reversed, here in this case what you are going to have, the length, balancing length here is 600 centimeter. Both are connected in series. That one, for the first length L1 here is E1 plus E2. Second one, this one EMF has been reversed, so here is L2, here is E1 minus E2. This is the concept. Hope you remember this one. From this one, from here, potential is directly proportional to the length. From this one, you just mention here, L1 by L2 equal to E1 plus E2 divided by E1 minus E2. So E1 and E2, both the cells are connected in series. Even V is proportional to R. Even resistance will be the same. All the potentials and resistance both are connected in series, means once the resistors are connected in series, R resultant resistance here is R1 plus R2. Similar in Ohm's law, V is proportional to R. Similar, battery potential also works the same. So here is V1 plus V2, or even E1 plus E2 here. In this one, E1 by E2 here is, you just simplify the equation. I just show you here how you are going to simplify this equation. See this one, you just cross multiply. See from here, I just mentioned here, this one L1 into E1 minus E2 here. This one I just mentioned here, E1 minus E2. So this one I just mentioned, in this case E1 minus E2, that one will be equal to L2 into E1 plus E2. Now you just cross multiply this, and E1 you just take it out. I just mentioned here, L1 E1 minus L1 E2 will be equal to, see here in this case, L2 E1 plus L2 E2. Now you just take it out, E1 on one side. Here is a L1 E1 minus L2 E1. That one will be equal to L2, already it is there, L2 E2 plus L1 E2. See from this one, I just take the common terms here. From this one, E1. Here is E1 will be equal to L1 minus L2 here. And here is E2 will be equal to L1 plus L2. See from this one you can understand here. So from next step here is, see from the next step, E1 by E2, this one from here, E1 by E2 here is L1 plus L2 divided by L1 minus L2. From here, first case L1 here is 800, second case is L2 here is 600. You just simplify this equation. So simplify it, what you are getting, that answer here is 7:1. Next question. So it's appeared like little complicated, but it's very simple. Direct questions only. See here, the ratio of the potential gradient, that is potential they have given 1:2 of the potentiometer of the same length. Length has been the same, no changes in the length. So you don't consider about the length. And the two potentiometer wire of the same length, but which is having changing the uh, resistance. That one is 2 ohm and 4 ohm respectively. What they are asking here is the current flowing through the circuit. The simple one, see, according to Ohm's law, hope you know about this one. See, already you know this one, V is equal to I into R. See, so this concept I just mentioned here, V1 will be equal to V1 by V2. I just mentioned here, V1 by V2 is equal to, this one I just mentioned here, I1 by I2 into the same one, R1 divided by R2. See what they are asking in this case, they are asking about what you mean by I1 by I2. That's all ratio they are asking here. V1 ratio already they have given, 1 by 2 will be equal to I1 by I2. That one we are going to find out. I1 by I2 will be equal to, I just multiply here, this one, R1 by R2, what they have given here is R1 by R2 here is 2 divided by 4, that is 1 by 2 here. And even this 2 will be cancelled over here, I just mentioned here. So from this one, what you are going to have here is I1 divided by I2 will be equal to 1:1. So the answer in this case here is 1:1. Next question here is, a potentiometer wire of length here is 10 meter. 10-meter wire of the length, which is having a resistance of 20 ohm, is connected in series with the resistance R ohm. So they have given, which has been connected to another resistance that is in R ohm. Already the wire which is having a resistance here is 20 ohm. A battery of EMF 2 volt with a negligible internal resistance. So internal resistance R here is negligible. The potential gradient on the wire here is 0.16 millivolt per centimeter. Now what they have given here is what is R value in ohms. Now for that, before going to that, first you just write down always what are the data has been given. According to this, the resistance of the wire here is 20 ohm, and potentiometer length here is 10 meter, and battery which is having a EMF is 2 volt, and gradient, potential gradient what they have given here is 0.16 volt per meter. Now this one here is what they have given here is in a millivolt per meter. You just convert this one millivolt into a volt here is 10 power minus 3 volt. Here centimeter, you just convert this one in meter, 10 power minus 2. So if you cancel this one, 0.016 volt per meter. Now current crossing through the wire according to Ohm's law, I is equal to V by R. V value here is a battery's EMF. R here is external resistance plus the internal resistance of the battery. Now substitute the value. Potential gradient here is this one. You just go through on this one. Potential gradient. Gradient here is potential variations per its length, changing the length. See this one. You just substitute the value of V here. V is equal to I into R. See, this is about I value here. R is there, and divided by length here is L. Now this one value already they have given. We found that value, that is 0.016 volt per meter. That one you just need to substitute the value. Here is 2 volt of EMF battery, and 20 is the resistance of the wire, plus 20 plus small r. R is a negligible value in this one, and 120 into, and this R you just consider here R of the external resistance. See, from this one R plus 40 divided by 0.16. So what you are going to have here is 250. Now from this one, see here 250 minus of this one total resistance, because that is connected in series. Already this is 20 ohm. The total resistance here is 250 minus 20. What you are getting here is 230 ohm. Now, next question here is the length of the potentiometer wire. See, the length of the potentiometer wire here is 200 centimeter, and the EMF of the standard primary cell here is E volt. So here primary cell battery value here is E volt. It is employed to the battery of, it has been employed to the battery of 0.4 volt balanced at L equal to 40 centimeter. See this one I just mentioned here. At here L equal to 40 centimeter, even they have mentioned here. See, from this one I just mentioned here, L here is 40 centimeter up to this point, right? So the total length here is, that is about 200 centimeter. That's what they have given in this question. See, from positive side what they have given here is from positive end, from the positive end of this one 40 centimeter. Next one, the E of the battery is, so what they are asking, E value of the battery is what, that's what they are asking. In this case, cell in the primary in this case is ideal, and the series is here is 0. For this one, for the previous session, previous questions we have seen, that is about the potential gradient. This one I just mentioned here, potential gradient in this case, K1 is equal to potentials per, potential here is E, potentials per the length. Here is for the first one, length here is E divided by 200 centimeter here. Similar in this case for the second one, K2 here is, I just mentioned here, this value here is 0.4 volt divided by 40 centimeter. Now this one in this case, what they have given here is E of the primary battery. That's what we have to find out. This one we have to find out. But the one conditions what they have given here is, that is about the primary battery here is, the primary cell is ideal. In this case, the potential gradient K1 will be equal to K2, or even that one will be we consider as K. See, from this one you just substitute the value here, E divided by 200, that one will be equal to 0.4 divided by 40 here. Now you just multiply this one. Say this 0 and 0 will be cancelled here. From this one, E is equal to 0.4, or even you just mentioned here 0.1. This 4 you just cancel this one. This is 0.1 here. 0.1 into 20, that one will be equal to 2 volt. So answer in this case 2 volt. Next question here is the EMF of the cell is 2 volt. Now EMF of the cell is 2 volt, and which is having an internal resistance here is 2 ohm. A resistance of 8 ohms here, a resistance of 8 ohm is joined to the battery which is in parallel. Now this whole connection, this connection is connected to the secondary circuit of the potentiometer. If so, now what they are given here is 1 volt standard cell balance. This one here is 100 centimeter of the potentiometer wire. Then the balance by point of this cell. What is the balance point of this cell for this one? Only if you consider this is 1 volt battery, means this is 100 centimeter. If you are going to connect this one to this secondary circuit, what is the balance point of this cell? That's what they are asking here. According to law of potentiometer, E is proportional to L. So E1 by E2 equal to L1 by L2. Here is E, and this one is potential is V here. See, from this one you just substitute here. For this case, first one what they have given here is, if it is 1 volt, in this case that is 100 centimeter. So 1 volt, that is L1 here is 100 centimeter. And for this battery, what you are going to do here is V is equal to E minus IR. This one you can see this one in the formula. E is equal to this one, IR here is again the same, that also a potential, right? This one also gives about the potential. E minus IR will be equal to 100 divided by L2 here. So 1 divided by E minus I here is, according to Ohm's law, here is V by R. V by R, V is about the potential, same like this one. So E divided by R, and this R, and the internal resistance of this battery here is R. Both are connected in series. So this one you can mention here is R plus R, and this R will be there. Now you just substitute the value. Remaining here is 100 divided by L2. Now substitute the value. 1 divided by E value here is 2. See, 2 volt has been given to this one. 2 minus 2 divided by, see, E value is 2, and connected with the resistance here is 8. So 2 divided by, and the internal resistance also they are given as 2. See, from this one, 2 divided by 10 into 2. So 2 divided by 5 will come. 2 divided by 5 here is zero point 0.6. So 2 minus point, so zero point 4. 2 minus zero point 4 here is 1.6. 1.6 into 100, what you are getting here is 160 centimeter. So answer in this case, there is 160 centimeter.